So as we'll see throughout this course, many studies may involve some aspect of deception, at least temporarily, where participants don't know something about the study, usually because the study wouldn't work otherwise. So for example, imagine you want to do a study on the behavior of cheating during exams. You could simply ask a bunch of students how much they cheat, but do you see any problems with that? I suggest you pause the video here and see what you can think of. For one thing, people might give socially desirable answers, or they might not believe you'll keep their data anonymous, they worry about getting caught, and so they say something that's not true. Whatever the reason, people might lie. They might even simply have forgotten some of the instances where they cheated, or perhaps they have a different idea of what counts as cheating, so they say they don't cheat when others would definitely count what they did as cheating. So instead, we might come up with something clever, like we might use deception in our research to get a more accurate and direct measurement of people's cheating behavior rather than self-report about it. So for example, we could set up a simulation of sorts, perhaps tell participants we're doing a study of math ability. We then give them a math test, like in a laboratory, and there's a clear opportunity for them to cheat. Maybe there's also motive. Maybe there's like a cash prize at stake in this research study, so they have an incentive to want to do really well. Then we videotape their behavior, like secretly, and we see if they cheat on this simulated math test. Now, obviously, if we had told them we're videotaping and that we're watching for cheating, that would totally alter their behavior and our data would be worthless. So that's an example of deception research, hiding information or even actively lying, but just temporarily for the sake of our study. And frankly, it is just sometimes necessary to properly study a particular topic. Obviously, though, that makes it harder or even impossible to get fully kind of educated consent, right? So we can get some form of informed consent, but we're not going to be able to give them all of the details. We can provide as much information as possible for them to then judge the risks and weigh the benefits, but without giving away exactly what we're doing in a way that would make the data useless. Basically, deception research, it's relatively rare, but it's to be used only when truly necessary and when we've kind of weighed up the risks and benefits of how important it is versus how much risk there is to them not knowing this particular detail. So because of that, it must go through a much higher bar to become approved, like by an institutional review board, an IRB. And they look very, very closely at this kind of research before approving anything. And indeed, that's because in the past such research has done some pretty questionable things. Just to take an example, in the 1960s, there was a study where 10 soldiers in an airplane were told that their plane was going down and that they have to fill out this insurance form quickly so that their family would get benefits, Well, the research question was basically, do people make more mistakes when stressed? You can see how that might be important for the military to know, right? But even though we might have gotten a very accurate real-world answer from this sort of study design, that doesn't necessarily make it worth the psychological trauma that may have been inflicted. And indeed, deception research always raises some big ethical questions that requires us to think about whether we can do, we may not be able to do studies like this anymore. So, perhaps the most famous example of deception research is the obedience experiment, or really it's a series of experiments done by Stanley Milgram, a researcher in the US who had heard the Nazis giving excuses during the Nuremberg trials that they were just following orders. They were just following orders when they did those horrible things. Now he wondered, was that true? Were the German people at that time really just unusually obedient as a people? Were they unusually willing to subvert their basic human empathy because someone in authority told them to do bad things? Or are we all of us humans, similarly susceptible to doing horrible things if we're put in the right social circumstances? He was a social psychologist, of course. So maybe it's more like this quote from Michael Albert, who said, "I have long since understood that the Germans weren't different than the Brits or Americans or anyone else, though their circumstances were different. But for those who still don't understand mass subservience to vile crimes induced by structural process of great power and breadth, I have to admit I mostly just want to shout, 'Look around, damn it.'" Basically, Milgram was wondering if Americans were all that different really from the Germans and all the things that the Germans had just done in World War II. Or if we too, as a people, might be susceptible to doing really nasty things if we're put in circumstances where authority requires it of us. He actually planned to try the same research study design first in America and then in Germany, to sort of compare the cultures, though he never got that far. So he started the experiments in America, and you may be familiar with the basic setup of his experiment. In the simplest version, he brought in a participant, but there was another person there who was pretending to be a second participant. So that's a big part of what makes this deception research. It had someone acting as a fellow participant. We call this in research a confederate. So in Milgram's study, the real participant and the confederate, pretending to be a participant, were going to be randomly assigned two roles in this experiment. They were told they were doing an experiment about learning and memory, except that the randomization of these two roles that they were going to play was rigged, so that the real participant always got assigned as the teacher role. And then there was a learner role that the confederate was always assigned, but they were pulling it out of a hat and it looked like it was random. So they were told then that the learner person, right, the confederate, would be in an adjacent room next to them, and over an intercom, the teacher, so this is our real participant, the person in the teacher role, would read aloud pairs of words, and then later do a sort of memory test for that learner person, the person they thought was just another participant. So like if the word pair was tiger and ball, then later on they might be told tiger by our participant over the intercom, and over the intercom the learner had to remember ball. Now, remember, our learner here is pretending through the whole thing, but the teacher role is the actual participant that Milgram was studying. And they were told that if the learner makes a mistake over the intercom, they should shock the learner with this shocking machine they were sitting in front of. It was labeled with switches from low voltage all the way up to very high voltage, full of danger warnings. So the participant even saw the confederate, the person acting as a learner, get strapped into the shocking device in the adjacent room, and the teacher role, the real participant, had a chance to experience the shock for themselves. So they gave them a little shock so they'd understand, so the whole thing would seem very real. Now in reality, the confederate was never actually shocked, right, over in the other room. Their replies and their reactions over the intercom were actually faked from a recording. So initially, when they get stuff wrong in the experiment over the intercom, they would get a shock. The recording might say, ouch! But the teacher, the real participant, was required to go to higher and higher voltage levels with each mistake. And on the recorded reaction of the learner, the responses that were faked got more and more serious, like complaining about a heart issue, asking to stop. At one point near the end, with a high voltage, they just went completely silent, like as if maybe they had died. Meanwhile, the real participant in the teacher role, sitting at that shocking machine, was told to continue, even then. So over the intercom, they were told, just keep going. They were told to continue throughout the experiment by a person behind them in a lab coat who was playing a researcher. They were just sitting behind them and saying things from a script, like, the experiment requires that you continue, or it is absolutely essential that you continue, or you have no other choice, you must go on. And indeed, Milgram's research never got past American testing because what he found here was shocking enough, no pun intended. In the most famous experiment, all but one person went to the 300-volt shock level. 65% of participants, so about 2/3, gave the final level of shock, despite the fact they seemed to think they were doing real harm to the learner on the other side of the intercom. Milgram actually did all sorts of follow-up studies to investigate the details of this kind of thing, like doing it on Stanford's campus for more authority versus a random-ass backstreet office in the city, or doing individual versus group, or with the authority figure being closer or further from the participant. But regardless, in these studies, Milgram used deception. He lied to participants, and they seemed to genuinely suffer psychologically. They showed signs of extreme stress, including that kind of uncanny nervous laughter that humans get that could be a response to really serious stress, things like that. Now, afterward, thankfully, he revealed the truth to them. He talked it out with the participants before they left that day. They saw the Confederate person, the actor, alive and well. They found out that person was just acting. They realized no one had been shocked at all. No one was hurt. They had not hurt or killed anyone. And when asked later, like much later as a follow-up, 84% of the participants, the real participants, were happy to have been in the experiment. And the other 15% or so were neutral about it, so very few, right? didn't like being in the experiment. Almost everyone was okay with it after the fact. Yet these experiments have led to like decades of debate on the ethics of deception research like this, and you simply aren't allowed to replicate the study nowadays, at least not like the original. Others have done more recent replications with like lower voltage labels and stopping it sooner, things like that. But even today, this is perhaps one of the most famous studies that we just can't do anymore. Now, another type of deception research would be studies involving a placebo, like with psychopharmacological studies looking at the effectiveness of a medication for some condition. So in that case, maybe like half of the participants get the medication, but half might get a placebo, meaning a fake treatment, like an empty pill or a sugar pill that's intended to make the patient think it's real, to make them expect improvement in their symptoms. We talk about the placebo effect as when changes still show up in a situation like this, even though the person got no actual medicine, no real treatment other than this pretend treatment. Now, obviously, the empty pill itself does nothing, so it seems to be that the belief, the expectancy of some improvement can, in some cases, for some things, lead to some amount of improvement. So why then are we doing this? Why are we using a placebo group as a control group rather than just a group that gets no treatment? Well, because doing so helps us remove a confound, a problem with our experiment, which is the placebo effect, right? It lets us know if the treatment, the actual medication or whatever, the thing we're testing as our independent variable, if that is what causes the improvement. Now, what do I mean there? Well, if we just gave half of our subjects the medication and half our subjects got no treatment at all, no placebo treatment, nothing at all, then what happens when our medication group improves? They get better compared to our control group. We might be tempted to think the medicine works, except that the devil's advocate, someone might come by and be like, no, maybe they only improved based on expectancy, based on the placebo effect, in which case our medication is doing nothing and the drug inside isn't really effective. However, when we instead compare our medication group to a group that has just as much expectation, just as much placebo effect, right? Then both groups, they have that equal amount of thinking they're going to get better and an equal amount where the placebo effect might kick in and cause improvement. At that point, if both of our groups improve the exact same amount, then probably their improvement was all due to the placebo effect. But if the real medication group improves significantly more than the placebo group, then that tells us it really works. Now, there's all sorts of research into the placebo effect itself, like why and how it works, the extent to which, all this stuff we don't fully understand at this point. We're still studying. It is important not to get the wrong idea, though. So just as a side note, the placebo effect does not mean something general like mind over matter, or that our mindset can overcome everything. Like, if someone is infected with gonorrhea, belief is not going to remove the bacteria that causes that. Placebo effects are not a good treatment for cancer. What they might help with are some of the things where we know the brain can directly affect processing, like with pain, for example. We know the brain can send descending signals down from the central nervous system to the peripheral nervous system that does affect things like the gate control mechanism that's involved in pain perception in our body. So in that case, it does seem like altering our beliefs, right, changing things in our brain, can cause some cascading brain processes that can temper or improve pain. But the placebo effect isn't some magical power of our mind to overcome all physical reality, and it isn't going to help with so many other situations where brain signals alone can't do that much. Okay, but enough of that kind of side note. Let's get back to the ethics of placebo use in research. There have been studies where people get fake surgeries, like what we might think of as a placebo surgery, because they're told they're going to get, say, this new heart procedure, and sure enough, they are put under anesthesia. Some of them do indeed get their chest cavity opened up, but no procedure is actually done on their heart. So in this example, this real example, the participants all thought they were getting the procedure done, and basically everyone showed some improvement, even though some of them didn't actually get the heart procedure. They just got opened up and then put back, closed back up, but they thought they got the procedure. So in this case, that tells us there's probably a placebo effect here for the people who feel their symptoms have improved later, but actually the real surgery is unnecessary. The real surgery doesn't help. It does no better than placebo, so it's not really a helpful surgery. So if the real surgery did no better than placebo, we don't want to do that procedure on people. Likewise, there have been medical studies where they do fake knee surgeries, and for that matter, more low-stakes studies about acupuncture, where they use what we call sham acupuncture, just meaning fake needles, pretend needles. It's like fake acupuncture where nothing actually goes into the skin, but it looks like real needles, that have shown that acupuncture doesn't actually do anything. So it's how we now know that acupuncture isn't real. It doesn't work. It's just a placebo effect where people sometimes feel better because they got that nice attention from someone, they were convinced they were going to feel better, and so on. But fake acupuncture works just as well. The placebo works just as well as the real thing. So all the theory and philosophy and claims of acupuncture are bullshit. We can actually learn a ton about what works and what doesn't, and why, if we use placebo controls in our research. So this is an area where deception can be precisely what lets us figure out if a treatment works or if a surgery is worth the risk. All sorts of important information. But when it comes to the ethics of placebos, it does mean you're knowingly giving someone no treatment. Like in a study for a new depression medication, the participants are suffering, and half of them won't be getting the medication that you, as the researcher, think works, right? You're testing that medication. At least you hope it works. So is it wrong of us as researchers to withhold that treatment from them if they're in the placebo group, right? If they're randomized to get the placebo instead of the real drug? Or to put it in even more blunt terms, in, say, a parachute effectiveness study for a new parachute design, who gets the placebo, the empty backpack with no parachute? How do you do that ethically? Well, people have thought a lot about this, and one solution would be, rather than having a placebo that's kind of an inert or empty placebo, you use a more, we call it an active control condition. So you could compare instead to a previous version of the treatment for that condition, or the existing or standard version. So what I mean is, like, imagine comparing your new parachute design to the old parachute design, rather than to an empty backpack with no chute. This strategy is actually really common in drug trials, where you might try your new drug against the old standard treatment, which we already know works, to some extent at least, right? So we might want to know if the new drug is better than this old one, or at least if it's just as good, but maybe it has fewer side effects or something like that. Now, yes, this research design does still mean that one group is getting worse treatment than the other, but we don't actually know who it is until the end. So it's not like, in this case, we're withholding the best treatment from half of them just to run a better study. We legit don't know which will end up better. But we still need the final element to make this okay, to make it ethically acceptable, and that is informed consent. So if you're comparing a new drug to an existing drug, or to an empty inert placebo pill, if you're randomizing people into one of those groups, you tell them that's how it works, and then you ask them if they still want to volunteer. So in a placebo-controlled study, you generally tell everyone there is a placebo control. Some people will get an empty pill. You just don't tell them if they're in that group or the real group. You, as the researcher, might not even know. So if the participant doesn't know, we say it's a single-blind study. And if the participant doesn't know and the researcher also doesn't know, we call it a double-blind study, and that's ideal. But like, the important thing is they know that they're in that type of study, and they have a choice. They can give informed consent if they still want to participate under those conditions, that they might be in a placebo group, for example, or that they might be getting the old version of treatment. Now, at the end of any study, but especially deception studies, there's an important phase, and we call that debriefing, which almost sounds like removing someone's underwear, but it just means taking time to explain the study afterward and check in with the participants. So this is when you'd explain any deception you used, explain why you used it, and make sure they understand the truth of things. Like in Milgram's study, it's important to see the learner, the actor, the faker, alive and well, and confirming they didn't get hurt by you, the participant. And now that you've revealed the deception in studies like that, you can ask the participant again if they're okay with their data being used, now that they know more details. As always, people have the option to opt out. And finally, it's a good time to reassure them, because you don't want people feeling dumb for falling for your deception, or feeling bad for doing pretend harm, or whatever it is. So think about it, like what would happen if Milgram had never debriefed his participants? There would probably be people out there potentially thinking they shocked a man to death in a memory experiment earlier in their life. That could be incredibly traumatic. Another element that's important to keep in mind to ensure a study is done ethically is avoiding risk to the experimenters, risk to any of the researchers. Like, imagine you're studying, the bystander effect. So your research question is whether people alone or in a group will be more likely to intervene if they see a sexual assault situation happening. Now your methodology might be doing like a simulated attack on a college campus where a man jumps out and grabs a woman who shouts, "Help me, rape, rape." Aside from the fact that this situation, just seeing it, might trigger, scare, or re-traumatize some bystanders, there's also a danger to the experimenter here. Like, what if some hero hurts the man, pulls out a gun, and shoots the researcher? The researcher is just acting as an attacker before they can explain that it's a study. Kind of like those idiots on TikTok who do horrible things in public and say, "It's just a prank, bro, it's just a prank," right before they get beat up for what they did. So we have to ensure any methodology we use to study something, even if we're doing it to try and make our study more realistic and generalizable, we have to make sure the researchers aren't put into danger either, especially since sometimes the person on the ground collecting the data or serving as a confederate is an undergraduate or a graduate student who's working for some professor who has power over them. Or to give a real example from history, when there may have been actually some danger to the researchers, there's a famous paper from 1976 studying shy bladder syndrome. Basically, where people sometimes have trouble starting to pee in a public restroom, the hypothesis was that personal space invasion is what underlies shy bladder. Basically, people at a urinal will have more trouble peeing the closer someone else is to them, so a person right at the next urinal makes it much harder to start peeing. So how did they test this hypothesis? In this study, experimenter 1 was a person, a confederate, who would come into the bathroom when some person was alone at the urinals and would either stand next to the peer or stand further away. So the independent variable here was just distance of this stranger when someone's trying to pee. Meanwhile, though, secretly, a second experimenter was hiding in a stall nearby and using a little periscope to watch the peer and measure objectively how long it took to start micturating or to start peeing. So basically, they were spying on someone's very private bodily function without that person's knowledge or consent. Now, whether or not they told people afterward, whether they did a debriefing, got their consent to use the data, stuff like that, whether or not that's the case, there was still some real risk there to experimenters. Imagine if someone had spotted the spying experimenter and gotten violent at the invasion of their privacy. So nowadays, it's important for an IRB, the Institutional Review Board, to consider the risk to experimenters as well as participants. Likewise, to consider any risk to others or to society more generally. Now, there's a lot more we could say about ethics in research, but I'll close by just emphasizing the number one ethical rule, which is to avoid lasting harm. Above all else, avoid lasting harm, be it physical or psychological, be it to the participants or experimenters or society. And in the big picture, these things I've talked about, they're all ethical guidelines, they're kind of rules, right? But you still need to follow all the applicable laws and check with your peers, your colleagues, the community, and make sure what you're doing isn't shitty. And use your own judgment as a human, because ultimately, you are responsible for ensuring that any research you do is done ethically. Now, it's a good place to stop for now when it comes to ethics from the research side, though in other videos we'll talk about the ethics of people making false or unsupported claims about products and supplements and things like that maybe allegedly help people and which they might claim are scientifically supported even when they're not really. There's all sorts of products and shills for products where they're just spreading bullshit. Sometimes true believers of their own bullshit, but often to make money off of those less educated in judging good research from bad research or in judging accurate scientific claims from inaccurate claims. So we'll come back to that later.